Hi girls, so just want to give you some feedback on the benzoic acid and just go through those exam questions that you did. So it was the 2018 was the first paper and it's question 2C. So if you can have your papers out, girls, because the screen on this is not great. I'm aware of that, but when I kept moving, I was making it worse. Okay, so sample of benzoic acid contains small quantities of sodium chloride as the only impurity was purified by recrystallization. So normally when you would have done this in the lab, and I know you didn't get an opportunity with me, but when you would be recrystallizing, there'd be more than one impurity, okay, and normally the impurity would be charcoal, or one of the impurities would be charcoal. So normally it looks kind of black grey, and benzoic acid itself is a white crystal, so you can see that it's impure straight away. This one they set up a slightly different way. So they said that there was only one impurity, and that was sodium chloride. So the big thing that you've got to think about, what's the major difference between sodium chloride, NaCl, and benzoic acid? So sodium chloride is ionically bonded and soluble in water, therefore. So that's a massive difference. The impure crystals were dissolved in the minimum amount of boiling water. So benzoic acid is very soluble in hot water, but insoluble in cold water. The solution was cooled thoroughly and the crystals that formed were separated by suction filtration, as shown in the diagram beside you. So why was there no need in this recrystallization to carry out a filtration of the hot solid? So normally that's what you would do, and that would be to remove any insoluble impurities like the charcoal. So you don't need to do hot filtration in this case because you don't have any insoluble impurities. The second, one advantage of suction filtration over gravity filtration, so it's faster and it dries the crystals better. And the last one, explain how you would verify that the recrystallization benzoic acid was purer than the original sample. So you would measure, and this is very important now in terms of the marking scheme, you need to say you would measure the melting points of both samples, the impure and the pure. And you would note that the pure melting point had a narrower range. So, for example, you could give numbers if you wanted. You could say that the melting point range in the pure sample was 106 to 108, whereas in the impure it was 98 to 120. So you note that the range is shorter, that it's a sharper point at which they change the melting point. The second one, then the next one you had was 2016, question 2C. And again, this doesn't tend to make up a full question because it's very basic, really. In the last few years, you're not going to see it. I wouldn't think it's a full question, but you will see it at small parts. So again, describe with the aid of a labelled diagram the method used to measure the melting point. So the things that they're looking for here is, have you given them a melting point block or something similar to a melting point block, and it's labelled? Do you have a thermometer in place, and is it labelled? Have you shown them some way of health and safety? So for example, I'd be looking, when I'd be taking a look at that one, did you mention heat resistant gloves? Or something along those lines, some sort of health and safety issue, because you're using something that's very, very hot and you need to have some way of heating that melting block. And things that would heat it for you would be, for example, a hot plate or something similar to a hot plate. Tend not to use a Bunsen burner just because it's not a great idea. So again, I would expect that I would see a melting block, I would see a thermometer, and I would see some way of heating that melting block, and a health and safety issue like a glove, for example. Part 2, the melting point range of F is lower and broader than G, which is purer, the pure sample. So G is the pure sample because F is broader, so G must have a narrower range. Also, you note that F is a lower melting point. When you're purer, you will have a higher melting point. And name a laboratory technique that could be used to purify impure benzoic acid, and the method is called recrystallization. So that is the method that you've got and to take a look at is recrystallization. The next one